Alright, this is going to be a quick tutorial slash demonstration about how to connect your PS3 controller to your Arduino, Uno or Mega or several other versions that I will list. Now before I start, if you're watching this video on my website, then the information will be in the post below. If you're watching this on YouTube, then you will have to go to the link to the post on my website to find specific information, because to save time I'm not going to talk about everything, just sort of an overview. Okay, now to get started, the controller first. Now you have to use a Sony made controller. Aftermarket brands will not work. Well, they may, but it's not confirmed, and to save money and time I would suggest just buying the legitimate controller. Now this will work with the Sixaxis or the DualShock 3. They're both listed here because Sixaxis means that it has an accelerometer and a gyroscope in it, and the DualShock bit means that it has the vibrator that the controller will vibrate, which you can actually access and control with this library, so it's kind of interesting. I did not originally want to use a DualShock because they're more expensive, but I could not find a straight-up Sixaxis anywhere, so I had no choice but to use the most fully featured and most expensive controller. I got this at Fry's Electronics for $40, so it's not too bad, and you can use it for other interesting things besides this. I don't actually have a PS3, I don't play any games, so this is totally for robotics and other things alone. Now, you will have to program the controller to speak to, or you have to set the master address that this is going to talk to, and as I do not have a PS3 controller, I do not know what effect this has on its connection to a PS3. Now, I know it's extremely easy to reset the master Bluetooth address that this is going to try to talk to, but I do not know how you retrieve that address from your PS3 controller if you were to want to put this back into the standard mode to play with your PS3. That being said, I haven't really looked because I don't have a PS3, so I assume it's not too difficult to reset it to the default address. The next thing is the shield you will need. I am using currently an Arduino Uno from Radio Shack. You can use a Mega and some of the older versions that preceded the Uno that were this general configuration. There is also available a shield for the Pro Mini, the strictly 3.3 volt board that's about a third the size of this in footprint. If you would like to use that as well. I do not have a Mini, I just have a Mega and an Uno, so I decided to buy the shield for this. Now, here's the shield. There are two places you can get this. This is a USB host. I have it upside down. This is a USB host shield, which means that it has the necessary hardware to route and, I guess, be the master for USB connections. So, as you may have discovered before, if you have a Bluetooth dongle, like this one, you are able to use this. It has some Velcro on the bottom to connect. If you simply plug it into the TX and RX and power pins on the Arduino, we'll wait for it to focus here. Right here, this is transmit, receive. If you plug it into the corresponding pins over here, and the power, you can talk to your computer through this. But this is a dumb device. It's what's called a Bluetooth device, and it cannot do anything on its own. It has to receive a request from a master, and then it simply routes information from these hardware here through Bluetooth via the antenna to the computer. The computer is acting as the host, or the master, the brain of the communication. Now, that means that this will not be able to actively seek out a connection with another Bluetooth device. So this and this together are pointless because these are simply devices. They can only be talked to. They cannot actively host any communication. That's why you need a host shield, which has the necessary hardware to do so. Now this is just a USB host, so it's general. It works with whatever you can plug in here. For the Bluetooth part, you're going to need dongles. But before I get to that, there are two places you can get a USB host shield. One is SparkFun, and the other is Circuits at Home, which is a sort of open source group. It's fantastic. They're actually the ones that host the library to run this thing. So I would I would like to ask anyone who does this to support them, because they were the original. They were they were behind this originally. Okay, so now comes the trickiest part. This is easy to get your hands on. This is easy to get your hands on. A working Bluetooth dongle is not so easy to get your hands on. I will, of course, provide the link to ones that have been confirmed working, and ones that you might try if you happen to have any lying around. I did not have any. All of my computers have built-in Bluetooth capability, so I had to order these two. Now, I had some trouble, and it's quite tricky, in fact, to get one that's supported. They say there are a lot of old D-Link type Bluetooth dongles work, but you're just going to have to plug them in and see. There's really no way. There are certain requirements for them that will be explained on the in a link to the sort of instruction page for this thing and the dongle selection helper. But these are the two I chose. This is a super cheap dongle I got straight from China. I bought two of them at once because they were each 99 cents, but these are factory seconds, so there's no guarantee that they're going to work. And I didn't actually notice that until after I had ordered them. I did kind of think, why are these so cheap? But I didn't read carefully. They were so cheap it didn't even matter to me. But I will show you what the condition the other one was in. I've taken it apart here, but as you may or may not be able to see, I'll use a wrench here. A capacitor, when I picked it up and rattled it around, there was something moving inside, and when I opened it, a tiny little capacitor fell out. And I've lost the capacitor, but clearly this did not work at all. It didn't even light up. So if you are to buy these, which I would actually recommend, I would recommend buying at least 5. At least. The shipping is very cheap, and they are only 99 cents each. But to be safe, I would say at least 5. Because maybe I just got lucky that I even got a working one. The problem is no one else sells non-factory seconds, at least that I could find. Now, here's the other and more disappointing dongle. This one I got from, I think it was like Micro something components. It was considerably more expensive. It was $14. It was listed as supported, or confirmed working, excuse me. But it did not actually work. I plugged it in, it powered up, there's a tiny little blue light inside of it, but I only got errors from the Bluetooth library, and after a while it wouldn't even recognize it anymore. Nothing happened when it was plugged in. I did get it to work with the computer, but I don't understand why it didn't work. It was confirmed supported, or confirmed working, but maybe they changed something in the internals. So, of course, I'll give links to all the ones that they have claimed to be supported and working. But do not buy this one, because it did not work for me. Now, maybe I just got a bad dongle, but I think not, because it worked on the computer. It recognized, I loaded the drivers, and it worked fine. So I think that they may have changed the circuitry inside the board, so it no longer works with this. So, again, buy this one, but buy a lot, because I have no idea what percentage of them are going to work. And they're so cheap, you might as well. Now, moving on. I already put this together. I purchased the disassembled version. You can buy 2 different versions from Circuits at Home. One is pre-assembled but does not have these headers. The pins simply come out of it, and there's no way to access them unless you add your own headers in these pins in here, which are tied directly to these headers. So I purchased the cheaper version that you have to assemble yourself, and it comes with these nice headers. So first you just plug it into your Arduino. This is going to be difficult to do through the camera. And of course, be careful with the pins. They are not very high quality, and they like to get bent. And there it is, the header. The shield has been attached. Now you just put this in. Now, the process that follows is you plug in your Arduino via the USB, and if you're using the Circuits at Home shield, you shouldn't need an external power supply. But if you do have an issue with it, plug in an external power supply, and that is apparently a common issue, that this is drawing too much power, so you'll need to supply it with external power. I did not have that issue with this one. It works fine on whatever power source I've used. Apparently the board that is the biggest issue on is the SparkFun version of this board. Alright, so I will open the computer here very quickly. Power this on. Now, I have to open it here very quickly. I am just running the example sketch that was supplied with the library for Bluetooth. Now, the USB host shield can be used for a multitude of functions, but one of the included one is communication with a PS3 controller. So, here is the library. Let's wait for this thing to focus. Once you install the library, you open the example PS3 BT, which I'm assuming stands for Bluetooth. Now, I had an issue with the library where when you download it from Circuits at Home, I'll have the link for this, it comes with dots and hyphens in the name, and the Arduino IDE does not allow for the Arduino IDE does not allow for dots and dashes in library names. You can't open folders of that type. So you will need to rename the library as I did. It comes as USB host shield 2.0 dash some stuff, and you're going to need to remove all dots and dashes, and I simply named it this. And clearly you will see all the headers and .cpp files and a folder for examples. And I am running the PS3 Bluetooth, so this is for Xbox controllers. I believe this is wired, but if you want to use any wireless, you go to Bluetooth, and here you have PS3 SPP, which is kind of a routing method for this, and then a Wii and SPP libraries. I am just running this one here, the example for Bluetooth. So if we go back to this, you will see this is the example opened from the file example sketch. USB host shield, Bluetooth, there it is. I have not modified it in any way. Just make sure that this is correct. I don't know why it wouldn't be, but this is going to be your biggest problem here and in your window, the baud rate. So if I am to start serial communication with the library, that would be through the hardware UART port here. You will see what happens. You will see library, PS3 library, Bluetooth library started, Bluetooth dongle initialized, HCI reset complete, local Bluetooth address, the thing listed afterwards, and then wait for incoming connection request. Now, I believe that this is actually hardware dependent on your dongle, this address here. Well, let me select just this piece. So once you have this, you're going to need to set the master address on your PS3 controller to that. Now, there are two ways to do this, one of which is easy, the other of which is not so easy, especially if you're on Mac. Now, the first way, an easy way to do this, is set up, download and install the PS3 example to your computer, as I did, and then upload it to your Arduino. Let's get the camera to focus here. Upload it to your Arduino, and then plug in your dongle. And this sort of thing should pop up unless you get errors. And if you're using the dongle I showed you, you should not get any. Then you simply take, here, let me set the camera down here. Simply, and it appears that hot swapping is not an issue here, which is really nice. You can just unplug the thing and plug it back in. So just pull this out. Okay, everything's still running. I'm going to plug a standard mini USB cable, the type that goes into the PS3 controller. So here's the other end of this. In here, to the PS3 controller, and you will immediately see over here on the computer that we have some new messages. Let's wait for the camera to focus. We have DualShock 3 controller connected. Bluetooth address was set to whatever it has read from the dongle already. So that's fantastic. You're ready to go. It set itself up. Otherwise, the other option is you can download this tool called the Sixaxis pair tool, which is actually designed to set up your PS3 controller to work with an Android device, so you can, play games on your Android with a PS3 controller. And but unfortunately, it's only available for Microsoft as a GUI. But there is a command line version for Mac that is too complicated for me to even bother. And as I have dual booted Microsoft and Windows, Mac, OS X and Windows, I chose simply to go with the Windows option. But I would highly recommend simply using a cable and letting the library set up the PS3 controller for you. So the next thing you do is just put this back in, and the light will come on, and you will get a repeat of the first message we saw. It just keeps writing out. It's not going to clear anything. So the beginning of the new message is here. This. Same thing as above before we plugged in the DualShock. Now I will show you what happens when you turn the DualShock on, because it has been, the address on it has been set to talk to a master of the address that has just been programmed. So when I press this button, which turns on the controller, you'll see the little lights blinking, and you will see that this starts to blink. This starts to blink rapidly, and this becomes solid, which means we have a connection. Now, we will have some new messages on the serial, the serial, what is it called? God, the serial printout on your computer. Now I have to reset this thing because I need this to be stable while we run. Okay, so you will see that we have a lot of new messages. It starts at the remote name, play, stop, in capitals right here. This is where the new message starts. And you'll see that it has gone through whatever configuration it requires, and then it says finally the DualShock is enabled. Now I will press L1. There we go. R1. Triangle. Circle. Cross. And square. Now press up, right, down, and left. This now is the left stick, and you will see that there are, well, actually what happens here is when you activate one stick, all of the stick is red. It just has it so that this is not spewing information continuously. So you'll see that I am moving the y-axis on the left stick. That would be right here. Let me find something to point with. Right here. I'm moving the left stick up and down. Now if I move the left stick right and left, you'll see the leftmost number change. Now if I go over to the right stick, you'll see that the right hat Y is moving, and then the right hat X. So that's all that. Now it's kind of difficult to push the sticks because they often activate the scrolling data feed out. But here, we'll try this. If I click the right stick, you see we get R3, and if I click the left stick, you see we get L3. A couple other interesting things is these triggers here are variable triggers, so they're not just clicks. You can see that they actually have sort of a range they go over. And you'll see that for R2. Let's wait for the camera to focus here. Come on. Oops. Okay, here you go. So R2 will go all the way from 0 up to 255 as I squeeze it harder and harder, or further and further. And L2 will also increase linearly from 0 to 255 as I squeeze the left bottom trigger, or L2. One other thing, or actually two other things, if you press select, you get a sort of a status readout of the controller. So it'll say, you press the select button, and then, come on, camera. Then you see this connection status is unplugged, power rating full, wireless status, Bluetooth, rumble is off. So it's kind of like an update on the controller status. Now, if you press the start button, something really interesting happens. You immediately get this high-speed feed, and if you look, you will notice that it is from what appears to be a gyroscope, given roll and pitch. And if I move the controller rapidly, you will see those rotational accelerations show on the screen there. I don't know how to access the accelerometer at this point, although I know the functions are built into the library. But apparently they only felt that the example needed to show the gyroscope. And it also only appears to show 2 axes. And I would think that they probably included a yaw axis as well somewhere, but you'd have to request it again. This is just the example code. And then that's it. You press start again to stop feed from the accelerometer. And the last thing is, if you push the big button in the middle, the PS button, the controller will turn itself off, the library, the Bluetooth connection will end, and you'll get this message. So now you'll see disconnect interrupt channel, disconnected control channel, oh man, come on camera, HCI, disconnected from device, wait for incoming connection request. And you'll see that now. After I pressed it, all the controller's off, and this is no longer blinking. Now, and this has been a little glitchy, if I just turn the controller back on, sometimes it reconnects and everything works, sometimes not. We'll see here. So, again, blinking, and it appears to have worked. Sometimes it doesn't. Sometimes you have to turn it on and off a couple times before it works. And there it is again. Starting up, all their startup information, and everything just works easily from there. So that's about it. The details and links to everything will be in my website post, which I will have a link to on the YouTube video. And again, don't buy this one, it doesn't work. The other 2 expensive ones listed may work. I don't know. I don't have money just to blow on testing every single one they say works. And this one does work, so I'd recommend buying these from the Chinese supplier on eBay. I will have a link to. Just buy a lot, because there's no guarantee all of them are going to work. That's it. Thanks for watching.